Next would be desired cash balance. How do we determine our desired cash balance using a quantitative approach? So using a quantitative approach, cash balance may be determined subjectively. Actually, that is the estimate that we can use. So we can use estimate here, or the thing that we would consider here is it the optimum cash balance? Actually, no, it would not be. Ideally, the optimum cash balance is zero, but if since it is essential to maintain a cash balance in operation, we can have a balance between the number of times that we convert our resources to cash and the cost of carrying them as available cash balance. So in doing that, we can use a quantitative formula that would balance that. What are the transaction costs? That would be the number of transactions multiplied by the cost per transaction, while the carrying cost would be the average cash balance multiplied by the cost of carrying cash. We can use the Baumol model in getting the optimum cash balance in this scenario, wherein the formula would be 2 multiplied by the annual demand multiplied by the cost per transaction divided by the carrying cost. All square root of that would be the optimal cash balance. So if you are familiar with the economic order quantity, it is a similar formula using different items. In here, the annual demand would be annual demand in cash. And then the cost per transaction in pesos, of course, and the carrying cost would be the rate. Using Miller-Orr model, we would have 2 multiplied by conversion cost multiplied by variances of daily net cash flows divided by 4 multiplied by daily opportunity cost. So when do we use Miller-Orr model? When cash flows are uncertain. If you would notice here, the formula considers variances. Then cash balance fluctuate between upper and lower limit. So we have a minimum and maximum cash balance here. So let's answer this problem. Once each year, X company receives a 2 million payment. Of this amount, 700,000 is needed for cash payments made during the next year. Each time X deposits money in its account, a charge of 2 pesos is assessed to cover clerical costs. If X can hold marketable securities which yield 5% and then convert these securities to cash at a cost of only 2 pesos deposit charge, what is the total cost for 1 year of holding minimum cost cash balance according to the Baumol model? So in here, we need to determine the optimum cash balance first. So what is the optimum cash balance here? That is square root of 2 multiplied by the annual demand of 700,000 multiplied by the cost per transaction of 2 all over the carrying cost, which is 5%. So that would be 2 times 700,000 times 2 divided by 0.05. Then we get the square root of that. So our optimum cash balance is 7,483 0.31. So that is in pesos. So we now compute for the transaction costs. How much would be, what is the formula for transaction cost? That is how many transactions how many times do we need to obtain cash in the year? So that is 700,000 divided by the minimum cash balance, optimum cash balance. So you would have 93.54 times. So the transactions would be 93.54 transactions, or 94 transactions multiplied by 2. That would be our transaction cost per transaction. That is 188. Then we have our carrying cost, or the opportunity cost of carrying it instead of investing it in marketable securities. That would be 5% multiplied by the average cash balance, which is 7483.31 divided by 2. So 7483.31 divided by 2 multiplied by 5%, that is 187.08. So your total cost would be, that is 188 plus 187.08, that is 375.08. So 374.17 actually is the amount that you will compute if you would use continuous computation. But in this case, it is better actually to use 2 decimal points or 2 decimal places, since you would maintain a peso amount of 748.31. And the transaction cost must be on full transactions, because you cannot do partial transactions. Okay? So the thing is, in using the optimum cash balance using Baumol model, the transaction cost and carrying cost would be close to equal. Actually, ideally, they should be equal if the amounts are in whole numbers. So moving forward, let's answer this problem using Miller-Orr model. So DF Corporation uses the Miller-Orr model to manage its cash account. Recently, someone asked how sensitive the solution for the return point and upper limit is to changes in the conversion cost, the variance of daily net cash flows, and the daily opportunity cost rate. The values that are currently being used are 50 conversion cost, 2 million daily net cash flow variance, and 8% annual opportunity cost. Calculate the return point and upper limit. So in here, what we will do is we will compute using the formula. So let's have the return point, which is square root of 2 multiplied by the cost per transaction here is actually 50 pesos, the conversion cost, multiplied by the variance of daily net cash flow, which is 2 million, then divided by 4 multiplied by daily opportunity cost. So the annual opportunity cost is 8%. So that is 8% divided by 360. So to compute for that, we have 8% actually. Yeah. 8% divided by 360, then multiplied by 4. We save that amount in our calculator, and we have 2 times 50 multiplied by 2 million, then divided by the amount earlier. Then we get the square root of that amount. So the answer would be 474,341.65. That would be the return point. And the upper limit, how do we compute for upper limit? That is 3 times the return point. So for the upper limit, we just multiply this amount by 3. Then you would have 1,423,024. So actually these are rounded off figures. The amount that are here on the answer are rounded off figures. So if we would use continuous computation, this would be our amount. That is 0.95. Okay, moving forward,